we're asked to find the forces in members CE and CG, so that's where we'll take our section through the truss. So I'm going to cut this part of the truss out and take a free body of it and draw in the remaining geometry to get a better visual. So this was node E, and over here we'll just call this the node CG. And we'll extend this dimension of 2 meters. And by cutting the truss, we've exposed the forces in these members. So because this force is a horizontal component, I'm going to guess that this member CG is being compressed. And because we've got an upward reaction at node A, the force in this member must be acting downwards to put that vertical reaction in equilibrium. And because this force is a vertical component, that's going to push the truss downwards, and I'm going to guess that this member AE is in tension. And now we need to be strategic on which equilibrium equation to use to find the forces in these members. So if I take a sum of moments about node E, with anti-clockwise being positive, well, we can see that the lines of action of all the forces pass through these nodes, except the vertical reaction and FCG. So what we have is the vertical reaction is √3 multiplied by the moment arm, and that causes a clockwise moment about this node. And then we have the force in member CG, and using the special trig triangle, if this dimension's a meter and this angle is 60 degrees, then this dimension's √3, which is the moment arm. So therefore the force in member CG is 2 kilonewtons. And a positive result means we got the direction right, so therefore this member is in compression. And now if we take a vertical sum of forces, with upwards being positive, we have the vertical reaction minus the vertical component of force CE. So that will be FCE sine of 60 degrees. And sine of 60 degrees is √3 on 2 using our special trig triangle. So therefore FCE is also 2 kilonewtons. And because that's pulling away from the member, this member's in tension. And please subscribe, like and comment to help me reach more students.